Welcome back, everybody. I'm very happy to be back with you. And on my side now is Professor Edward Kosior. He is the managing director of Nextek Limited. And he was here before yesterday in the evening, at least for us, for a very nice panel discussion on the whole theme of innovations in recycling. But now he will take us a little bit deeper into his own field and will tell us all about closing the loop on food grade PPP. So their big project right now is NEXTLOOPP. So to get a really circular economy, looking at that. Edward, so good to have you. Thank you for being here.
Thank you, Felix. Thank you for inviting me to come back a second time. It's a pleasure to participate in webinars like this because I think not only will we talk about the technology of the future, but we're probably going to practice in this type of way in terms of communication, no doubt. So well done for being a pioneer in this area.
Thank you. Thank you for joining us for that. I've got to tell you one thing, because Edward is right now in Australia, and so it's nighttime for him. So give him a special thanks for joining us right now. But yeah, let's dive right into the presentation. Let's go.
My name is Edward Kosior. I'm the Managing Director of Nextek. Nextek is a technical consultancy that specializes in the recycling of post-consumer plastics. We also develop unique solutions and innovations that can boost plastics recycling. Today we're going to talk to you about one of our recent innovations on the recycling of polypropylene back to food grade. This is really a story about a response to the circular economy that we're trying to develop. We currently know we have a problem with the way we manage plastics. Plastics are spilling out into the environment. We want to close the loop. We want to create a circular economy so we can actually use less virgin material and recycle more for our everyday uses. And this is the story of NEXTLOOPP. Polypropylene is one of the most widely used and manufactured plastics globally. It's used from many things, for straws, food items, drink containers, textiles for masks and surgical areas. It's used in the automotive and the electronics industry, and it's even used in many banknotes as the plastic note that we're very familiar with in many countries. It's a widely versatile material, and this is indeed one of the reasons why it has not been so widely recycled. In 2018, the world made 56 million tons worth nearly 100 billion US dollars. By 2025, that will grow to 83 million tons, and in Europe, we currently use 10 million tons, a very substantial amount of material. And of course, polypropylene is one of the most versatile materials that's been made. It's quite stiff and very light. It's insoluble. It's very strong. It can be very tough. It can be virtually glass-like transparent, and it can be made into a myriad of products, from fibers to sheet to moldings to furniture, appliances, automotives, and packaging. And this is why it's widely produced, and some of these very versatile applications are some of the reasons why it's not widely recycled. The demand for polypropylene in Europe, as I said, is over 10 million tons, and we can see that it's widely used by many countries, and for the big 6 European countries, they use over 500,000 tons to up to nearly 2 million tons in the case of Germany. But this just shows the wide use of polypropylene. It's used in many applications, as I've mentioned, but over 40% of polypropylene is used in packaging. And this is quite important because packaging can be short-lived, and that means it may serve its purpose and then be discarded. And where does it get discarded to? In many cases, it does not get recycled back into the original application. Recycling of polypropylene packaging in Europe is approximately 10%. In the United States, the recycling of polypropylene could be as low as 5% in some locations. Let's have a look at the United Kingdom statistics. In 2019, United Kingdom used 700,000 tonnes of polypropylene, with approximately 290,000 tonnes used in the packaging sector, and 70% of that is food packaging. And of the food packaging, we know that 61,000 tonnes of pots, tubs and trays were collected out of an approximate amount of the order of 80,000 tonnes. And yet the demand for recycled polypropylene is much higher than what has been collected. And this is why we have developed the NEXTLOOPP process, which we'll explain in a bit more detail. But let's hear first of all from Sally Beacon, who is from the Knowledge Transfer Network in UK, about why we would have a process like a food grade polypropylene material.
The need for a food grade recycled polypropylene, well, we should, first of all, just as a moral reason, we shouldn't be wasting valuable material. Most of it's going to landfill or incineration. But right now, more urgently, it's being driven by legislation. So this March, the UK budget announcement of a proposed plastics packaging tax will mean that there's actually a driver towards needing recycled grade materials, and that's around £200 a tonne. So it's a need and a moral obligation, I believe.
The NEXTLOOPP project is a multi-client project made of companies that represent the supply chain of polypropylene. It will include companies from the manufacturing of the resin to the converters, the brand owners, the retailers, the recyclers and the technology providers, as well as industry associations. And the whole focus is to boost the circularity of recycled polypropylene. And it will help brand owners reach their packaging targets with recycled content. As we know, recycling is one of the key areas of focus for nearly all countries as a way of tackling the destination and end of life for many forms of materials, including packaging materials. And this is why we have developed the NEXTLOOPP process. Brand owners globally have spoken about their targets for the future. You can see on this slide that some of the very well-known names have already set targets for recycled content by 2025. And we know that they are looking for ways of achieving high levels of recycled materials to create a circular economy for the products that they put onto the market. And this can only be achieved if we make high quality recycled materials, including polypropylene that can be reused back into packaging. And in this case, especially food grade packaging. We have spoken to the supermarkets and asked them what their targets are for the near future with their packaging. Marks and Spencer have clearly told us that they want to find circular economy solutions and welcome the introduction of a program like NEXTLOOPP. Co-op have got substantial targets for their use of plastics and want to reach 50% recycled content in all plastic containers where possible. Tesco also want to see a circular loop for polypropylene. They currently know that there is a shortage of food grade polypropylene and welcome the introduction of a project like NextLOOPP. Morrisons also acknowledge that food-grade recycled polypropylene will become a key factor in the future. If it's not available, then they would need to switch to other polymers like recycled PET in order to reach the recycled content needed to avoid the new taxes that are coming up in United Kingdom and potentially elsewhere. Iceland have been committed to becoming plastics free, but that still doesn't mean they won't use plastics. And where they do use plastics, they'll want to use recycled content. And food grade recycled PET is seen as a critical and important step to ensure that the plastics they do use stays within a closed loop. So this is why we've created NextLOOPP. Its mission is to create the circular economy for food grade recycled polypropylene. And we're going to do this by establishing a supply chain model for collection, sorting and reprocessing of food grade polypropylene packaging. We will establish efficient manufacturing of high quality and food grade recycled polypropylene at both pilot and large scale operations. And we will develop a series of resins that will be able to be used in processes in a wide range of products so that brand owners can reach their recycling targets. The NextLOOPP project will deliver a number of milestones within the project. We will develop the infrastructure and the systems for the collection and recycling of polypropylene so that those materials can be upgraded to food grade quality. We will produce food grade polypropylene for reuse back into consumer products, including food and also cosmetics. We will establish certification by EFSA and US FDA for the manufacturing processes. And we'll start the recovery of branded polypropylene products for recycling. In addition, we will introduce enhancements to the decontamination processes that are a key part of the NextLOOPP process to boost the economic efficiency and to reduce cost. And we will develop a range of specific grades of polypropylene for film, sheet, thermoforming, blow molding and injection molding. And we will increase the recycled content to above 30% and going to higher levels as well to ensure that recycling targets can be met, but at the same time ensuring processing stability for monolayer and multi-layer structures. One important milestone which we'll develop with many of the partners in the project will be the design guidelines for food grade recycling. This element has been missing from the design of plastics packaging, and we want to introduce this so that the recycling of polypropylene can continue to improve over the years. Let's hear from RAP, from Peter Maddox, who was the director of RAP, about the recycling of polypropylene.
Well, I think first to say it's really important that polypropylene is a really valuable and versatile material. We've got some amazing barrier properties, which is why it is so widely used in food packaging. I think the challenge is that currently all food grade post-consumer packaging is currently downcycled to non-food grade materials. It goes into pallets, trays, crates, and it even goes into the automotive sector. That's the challenge for polypropylene packaging.
Let's hear from Dr. Ralph Uping from TOMRA about the challenges facing the recycling of food grade polypropylene.
I can think of two barriers. So the first one is the missing certified recycling processes certified by the EFSA. And the second barrier I see is how to get food plastic separated from non-food. So this can be first organizational, like in PET with a deposit system, collecting it separately, but technically it could also be sensor-based sorters, which are able to distinguish between food grade or non-food. And these are the barriers, I think, which are missing. If we want to tackle the plastic problem, then we need to invest into technology here, because the potential is quite big. And I do not see any reason from a technical point of view why we could not achieve with polyprop what we have already achieved with PET. So there's the technology on the one side, but of course at the same time the technology needs to address the concerns or the regulations of the EFSA.
So Ralph has pointed out that there are challenges ahead, and let me summarize them. The feedstocks need to be sorted prior to recycling, and we need to separate food grade materials to at least greater than 95% purity. The European Food Standards Authority, EFSA, they require detailed documentation to validate that under the challenge test protocols, high rates of decontamination are reached. And of course, any finished product needs to meet the migration test conditions specified for a range of food contact applications. The recycling processes have to be economic and competitive with comparable recycling solutions. And of course, we need to be able to develop grades that can be successfully used for conventional extrusion and molding operations for products like thermoformed pots, tubs and trays, film and textile applications. And we will also need to be able to meet the various standards for food and also for cosmetics. And we will also be able to introduce a new grade called an inert grade recycled polypropylene. NEXTLOOPP has developed a number of solutions to meet the challenges that we've just outlined. In the decontamination tests, the process has demonstrated that we can meet the challenge test requirements of EFSA and US FDA for direct food contact. More on that very shortly. NEXTLOOPP can meet all of the necessary migration conditions for all aqueous, acidic and alcoholic food simulants, and indeed for a wide range of oily migration conditions as well. The feedstocks for the recycling of polypropylene will initially come from closed loop sources, but ultimately they'll come from the commercial sorting of packaging. And we would seek to implement the fully proven PRISM market technology system to conduct that sorting. We have already conducted full-scale production on sheet lines and injection molding to show that this technology can be very successfully implemented and meet the migration test conditions that we've spoken of. Here are some examples of products that have been made and then blended for thermoforming and injection molding at levels of up to 50%. And you can see here that we have got clear and colored variants of these two materials. The properties of recycled polypropylene are comparable to virgin copolymer resins, and when they are blended with virgin materials, they can be used as a direct replacement in many applications without any impact on the processing conditions and the physical properties of the finished products. The process that we've used has been evaluated by Pyra and by Steptoe and Johnson, and their conclusions are that for the various stages of the process that we do meet the food grade requirements for EFSA and US FDA for direct food contact. The PRISM marker system is plug and play ready. Nextek developed this over the last 6 years based on a library of fluorescent markers that respond to ultraviolet light and give a visible signal that can be read by existing NIR visible automatic sorting machines that are used widely across Europe, the United States and other countries. This is all being done at very high speeds and at over 2 tons per hour per meter width of belt. And we can achieve greater than 95% purity in a single sort and greater than 99% purity on a double sort. This means we can use this technology very quickly for the separation of polypropylene food packaging from non-food. And equally, it could be used for high-density polyethylene and PET as well. Here's a video demonstrating the recycling of polypropylene while it's been mixed with post-consumer materials. And here you can see that the materials have been mixed with, in this case, sleeve bottles with the marker, and they've been mixed with post-consumer plastics and then resorted. And you can see on the belt the marker technology is being detected and separated from the conventional materials. And in this trial, both the red and the blue sleeve packaging were targeted, and you can see that they've been separated at very high rates. Let's hear from George Fern of Brunel University, who is one of our supporters on fluorescent markers.
It can have a major positive influence on recycling. What I like about the technology is that the home consumer doesn't have to do anything different for their plastics to be recycled, so long as they leave the PRISM label on the packaging. So as long as you put in your waste, general waste, like I do here, into my general recyclables refuse collection, and ultimately that will find its way to the plastic recycling plant, and using the PRISM label, that will be automatic recycled.
The PRISM marker technology has already been evaluated on an industrial scale at general purpose recyclers in Germany using the TOMRA detection systems. So in under 1 hour, we've been able to go to an installation, install the software and the necessary lighting system, and start to sort fluorescent marker bottles. So the PRISM marker system can be used and implemented on existing machines in under 1 hour. This is plug and play ready right now. Let's hear from Jude Allen from the Institute of Materials about why there is a need for the circular economy and for the recycling of polypropylene.
So the obvious answer of why it's important to work towards the increase of recycling of PP is to save the world from plastic pollution. And the second, slightly more detailed thing is about there's some circular economic principles that is just so important to try and keep materials in use. Materials have value, and if we can realise the value, then why throw it away? We want to keep plastic in the economy and out of the natural environment. And anything that works towards increasing the recycling of materials is in an effective and economic way. It's got to be a good thing.
Following on the words of Jude Allen from the Institute of Materials, let's move to Stuart Foster, who's the Chief Executive of Recoup, one of the organisations in United Kingdom that is supporting the recovery and recycling of plastic packaging. In their case, they see NEXTLOOPP as a critical and an exciting opportunity to reach the recycling targets, especially for polypropylene, that have been missing to date. And this will allow us to maximise resource values within the circular economy. This brings us to the NEXTLOOPP project and the driving forces. There are taxes mooted in United Kingdom and Europe for packaging with less than 30% recycled content that is used in single-use applications. The NextLOOPP project has a total project cost of over £400,000, and yet to participate, only a small fraction of that is required from any one participant, which means that the benefits will come to companies for a much lower fraction than trying to achieve these goals on their own. NextLOOPP will use recycled polypropylene to manufacture a wide range of products, and this means brand owners and converters can experience and test and validate that they can use recycled content in the many applications and processes that are used to manufacture polypropylene food-grade products. And equally, we'll be able to solve any of the problems that companies have faced in the past when trying to recycle polypropylene back to food grade. So, in summary, the NextLOOPP program is here to close the loop on polypropylene packaging. It's the culmination of over 8 years of work and research and commercial trials to bring this concept to a commercial reality. We are now looking to launch this as a multi-client project, and we welcome inquiries and support from organizations that have an interest in seeing the circularity of polypropylene improved and launched on a larger scale. And we hope that this will become the next holy grail of recycling. We know that there are many issues with the use of plastics packaging used globally, and we look forward to the support of companies like the ones listening to this webinar, and we look forward to your support and engagement. Thank you very much.
Well, thank you so much, Edward, for that presentation. Really a very nice, straightforward project. We are here now to answer some questions. You can join in with your webcam as well again, if that's working right now. Otherwise, audio's fine as well. Perfect. There, I can see you now. Thank you. One of the questions coming in here is if you see on the short time a possibility to develop a food grade PPP process for mechanical recycling as well, or do you think will that be chemical only?
Okay, this is indeed a mechanical recycling process which we have worked on. It's technically quite difficult to achieve. That's why it's taken some time to bring it to the marketplace. The requirements of EFSA are very tight, and they require very stringent decontamination technologies. So this is what we've been working on to establish. But indeed, this is mechanical recycling. And the reason why we developed it is that we can build a mechanical recycling plant almost anywhere in the world, whereas you cannot build a chemical recycling plant anywhere. You would be restricted to the petrochemical zones. You have to feed it into a cracker, which then can make materials. And so you can do that, but the carbon footprint of chemical recycling will typically be higher and the costs will be higher. So we can, without waiting, we can start to recycle PP. And I think that is the message. The world can't wait for the recycling of all the plastics. And PP is the biggest single plastics made in the world today, and yet it's one of the least recycled given its proportion of volume on the market. So that's why we decided to go and make this mechanical recycling process. And
Sure.
We want to see it implemented commercially.
All right, yeah, then I understood correctly. Sorry, I think the question came in the beginning of the webinar, so
Yeah.
maybe it was already answered by you. Thank you for that clarification on that side. Do you have maybe some insight on what would you say, at what point in time will we be able to have a system like that starting?
So the plan for NextLOOPP is to build a demonstration plant. So the plan is that by the middle of next year, we will actually start the planning for the construction of the plant. And by the middle of 2022, we should have the plant producing material. So we're already doing the preparation within the project. We've got companies that are bringing material for us to use, and we have companies that want the offtake. So they are already queuing up. So in between, we have companies that are already putting their name forward for investing in the plants. And not only do we have one in Europe, we also have a very advanced inquiry from the Asia Pacific area. And then we have two others, one in the USA and one in one of the other continents, which I can't say anything about. But it's very pleasing to see companies realizing that this will be the next wave. And when you think of the production of PET packaging and high density polyethylene packaging, it's highly developed. And there's no reason why polypropylene can't be as widely recycled as PET and high density polyethylene. And this is really what the NextLOOPP project is going to be. And the other thing I'll mention is we believe that because it's a mechanical recycling process, it will be economic. It won't be expensive to build. It can be done with machinery that's currently available. We don't have to invent anything. It's all been done, and we just now need to commercialize it. And so that's our focus, to put together all of the work we've done in the area of separation and sorting and decontamination, and supply these as packages to the recycling sector and to brand owners, so they can actually put recycled content back into their packaging.
Yeah, regarding that, the questions coming in about, can you maintain the quality of the polymers over multiple closed loop cycles?
And that's a very important question. So at the very beginning of this, we intend to reach the boundaries for taxation. And the reasons for this are very simple. There will not be a lot of resin for use at the very early stages. So our initial targets will be at 25 and 30%. And we have already demonstrated successful looping of the material at 40%. Now, what this means is you have to be sensible about the recycling strategy and the way you structure the particular products, but we can have stable production at levels of the order of 40%. Now, beyond that, there's no point going and speculating further, because we need to build up the capacity. Now, in closed loops, eventually you will find that materials will get fundamentally degraded, but then we can go to chemical recycling. But if someone said, show me the next chemical recycling plant, well, it just doesn't exist, and it won't exist for another 5 years perhaps, unless it's a pyrolysis plant where we make oil. So chemical recycling is at its very early beginnings. So we need to start right now on polypropylene, and hence our technology, what we think is the right way to go.
Perfect. Yeah, sure. Going on with that, what can you tell us about these prism traces, especially when you think about a closed loop where we will have maybe a concentration of these in the material, or what will happen with these, especially looking at the quality and sanitary aspects?
Okay, so the traces we're putting onto the package are going to be located on the label. And of course, we'll make sure when we put a label on that it will come off. And right now, the industry has access to self-peeling labels in a washing system. They're not widely used, but they are available, and they have been available for a long time. So we want to make sure that we have the same thing. So then we can recover the labels, separate them out from the process, and then potentially recover the markers from the labels. Now, we've already done the work, and we found that when we recycle the material with the markers on the label, we can get complete separation and have zero concentration in the finished polymer. And of course, some people keep asking, why don't we put traces in the polymer? Well, the idea is to keep the polymer pure and to avoid false positives if they get used for non-food in between. So it's quite clear what to do. And I will say that the recycling of all packaging starts with the design, and we understand what's required as far as recycling materials goes, and what is capable of being done right now.
Perfect. Thank you, Edward. Thank you all for joining. Thank you for your questions, Miguel, Lucas, Christine. Thank you for participating and interacting with us. Thank you so much. To all the others, thank you so much for being here, attending, doing the convention with us. I would invite you all to our next webinar at 5:15 with Eric Hagen from Weimar, who will talk a little bit about shredding technology. And Edward, so much thanks to you for joining again with us, even in nighttime. And of course, the last words are yours.
Yeah, no, thank you, Felix, and thank you again for organising the time. It's been a pleasure to speak to you and your audience, and we wish you success in the webinar. All the best.
Yeah, we wish you all the best, and hopefully we will soon have a lot more recycled PP in our food. Thank you. Not in our food, but around our food, of course. Thank you so much. Have a nice evening. Bye-bye.
Goodbye. Goodbye.